So this is going over a practice set of IR Spectra, just to give you a feel for what you're going to be doing with this. For this, you need your IR band table that you have available to you, and this is the practice IR Spectra. There's 4 different spectra we're going to look at. So again, what you will see is wave number, and again, it kind of goes from right to left, and this is percent transmittance. This is just in decimal form. And what you will see are these bands, okay? And some of the bands are going to be labeled for you. Again, we are just looking pretty much towards the left-hand side here. Is really where we're looking for the functional groups. So the first thing you do is you take a look at the formula of C7H14O and you do a degree of unsaturation to kind of see what kind of bonds you have in there. So I have 7 carbons, I have 14 hydrogens, and oxygen does not count. So I get a degree of unsaturation of 1, okay? With 1 oxygen, okay, this eliminates some functional groups, like I can't have an alcohol because alcohols are all going to be single bonded. I can't have carboxylic acid esters because I don't have 2 oxygens. I can't have an ether because, again, that would be all single bonded. So chances are my saturation or my unsaturation point is a C double bond O. So what 2 functional groups do you have? You have ketones and you have aldehydes. So really this is where degree of unsaturation helps you to kind of narrow down your focus. Because again, this table I've given you is very small. Okay, there's much larger tables that you could find, but I kind of boiled it down to what we're going to be looking at. So what you look at is, all right, so what kind of peaks are going to, bands am I going to really focus on for aldehydes and ketones? So I look at these 2, and I see that for aldehyde and for ketone, I have 2 bands that show up for the CH, both at the same place, about 2690 to 2840. So that band, which is probably somewhere over here, okay, it might be underneath some other things, really are not going to distinguish an aldehyde from a ketone. But I do have in the 1700s the C double bond O peak, okay? If it is on the lower end, it's going to be more of the ketone. If it's more on the higher end, it's going to be more of an aldehyde. So what you will see me label are some key peaks. So this is at a 1730. And again, this peak over here is probably your double bond, your 2 bands that they're referring to. But you also have probably a CH there. And again, any CH is going to be, right of the 3000. So you got that as well. So you don't have any double bond or triple bonds because you got nothing left of 3000. So the 1730 is really what I'm focused on. And I look and I see, oh, well, if it's 1730, I got to be more in the aldehyde region. So this tells me I have an aldehyde rather than a ketone. So all I'm going to ask you to do with these formulas is then to draw me an aldehyde. So just draw me 7 carbons, 1, 2, 3, 4, 5, 6, 7, and make an aldehyde on the end, because again, that's what an aldehyde has, is an end group, C double bond OH, and you are done. Okay, now is it all a straight chain molecule? Don't know that. Okay, does it have branches at different places? Possibly. And if we had the fingerprint region, anything in the 1000 or below, this could possibly tell us. But again, organic chemists don't use IRs for that anymore. They just use it to identify the functional groups. So boom, I have an aldehyde. I could then move on to more information. Okay. So flip that over possibly and find the C4H8. C4H8. So again, always do your degree of unsaturation, okay? That's always your first order of business. So I have 4 carbons minus 8 over 2 plus 1 gives me a degree of unsaturation of 1. Now it's only carbons and hydrogens, and I could possibly have, I could have a ring, okay, but I don't really have much data on that, but I possibly have some kind of double bond, okay? Now, if I have a double bond, I would see peaks for alkenes, okay? So I have anywhere above 3,000 is going to be something with the double bond, okay, between the carbon and the hydrogen. And you will see that sometimes it's labeled as sp2 carbon, and we'll talk a little bit more about that as well. But then you have like a peak in the 16s that also has the double bond. So I've labeled two places here, the 3100 and the 1650. That's telling me I probably have some kind of double bond, okay? Now again, with that small of a structure, you could possibly have a ring. Not to say that that's not possible, but I don't have enough information on the IR. Maybe if I had more peaks labeled, maybe that would give that to me. But instead, I'm just going to call this an alkene. Where is that double bond? We will get more information going forward. Okay, so flip to the next two. So C4H6, see if you could do the degree of unsaturation, see if you could figure out what the functional group is by what I've labeled there. And then try the last one, the C4H8O2, and I will come back up and unpause the video and show you the answers. So looking at the C4H6, my degree of unsaturation turned out to be 2, okay? So probably I have some kind of triple bond in there. Again, I could have like a cyclo and then a double bond in there. But if I look at my IR peaks that I've labeled here, I got a 3320 and a 2125. So if I look at my alkynes here, I got a 3300 is going to be that CH, and again, that triple bond just pushes that band. And then I got somewhere in the 2100s that's going to give me my triple bond, okay? So again, you're going to see, you know, key peaks popping up. And anytime you see somewhere in the 3100 or anything beyond 3100, you know you got to have some kind of triple bond. So again, I just want you to draw a triple bond somewhere in that structure and call it an alkyne, and you are done. Okay, and again, we will get more information from other stuff. Then we have our last one, which is C4H8O2. Degree of unsaturation turned out to be 1. Since I have 2 oxygens here, that's going to limit me to esters and carboxylic acids. So I got really 1 peak here, and I got nothing, you know, I got around the less than 3,000 here, so I know I got some CH bonds, but I don't have anything significant that I need to worry about. So it's really the 1750 peak that I'm looking at. So then you got to look at, all right, well, what kind of peaks do I have for an ester versus a carboxylic acid? Well, both of them have the C double bond O, but as you could see, the higher 1700 is going to be more of an ester. And the thing that you're missing here for the carboxylic acid, because carboxylic acids have an OH group, okay, so carboxylic acid is C double bond OOH. You typically have some kind of big, broad peak here if you have a carboxylic acid, okay? Really, really big peak. So immediately I knew it couldn't be a carboxylic acid because of that, okay? It's very unique for carboxylic acids because of that OH essentially is kind of intertwined with some other things in there. So then I have to have some kind of ester here. So all I would want you to do is to draw a proper ester. And again, how many carbons do I have on either side is going to be figured out later. But as long as I have an ester group drawn with the correct number of carbons, that is what I'm looking at for this activity.